Hello everyone, I'm Levente Halmosi from the University of Szeged. I will talk about our recently published paper evaluating the adversarial robustness of semantic segmentation. Try harder pays off. So, as you might know, adversarial examples are a pretty popular topic in classification, and not surprisingly, we are able to create adversarial examples against segmentation on neural networks, and here you can see an example of it. So, our problem statement. So, basically, there were a lot of paper published about robust semantic segmentation, and there are some strategies which show some kind of robustness against a small set of attacks. And our motivation that we found pretty suspicious that the robust models clean accuracy and the standard models clean accuracy are pretty close to each other. Therefore, we can't see the trade-off, which is a pretty well-known phenomena in classification. So our research questions: how robust are current models? Which attacks are most effective? Does object size influence vulnerability? So when you look at the table, you can see our scope, the architecture, the datasets, the training algorithms, and the attacks. So basically, we evaluated every combination of the architecture, datasets, and training algorithms in the scope, and we evaluated these models with the example of attacks, and we use the naive example. So basically, we run every attack on every image, and the combination of the worst result was the result of these measurements. So we basically made a very wide range of evaluation. So about the methodology, we created two novel attacks. So these two attacks are basically just variants of the standard PDG algorithm. We integrated an ADEM optimizer in the standard PDG, and we used two different kind of loss function. The first was the standard cross entropy, and the second was the cosine similarity with one-hot encoding. During our research, we identify a very interesting phenomena, which is the size bias. So most of the cases, the models were able to identify correctly the huge objects, but they weren't able to identify the small object accurately. And because of the aggregation of the standard aggregation of MIOU, we can see pretty high results, but it was just the problem with the metric, not the correct result of the model. Therefore, we created another aggregation strategy for the MIOU value, which is aggregate the results over the images, not over the classes. Therefore, it is able to show the size bias of the models. Let's talk about the results. So the vulnerabilities. In this table, you can see a subset of our evaluations, and as you can see, most of the models are not robust at all. And when you look at the SegPDG-EC algorithm, which looks like robust when it comes to the accuracy, it is not robust at all, because the MIOU, the CMIOU and MIOU value are pretty low, and these results are under the standard persistence model, which is just a constant predictor. So we can say that these models are robust. So the size bias, as I mentioned, we identify size bias in the models. Here is just a simple example of size bias. So when you look at the huge bird, you can see the C tiny and the SegPDG models were able to identify the huge object correctly. And in the second case, when the small birds are on the image, these models were unable to identify the birds correctly. So it is just an example of the size bias that we identified. So in this image, you can see the distribution, the IOU value distribution over the datasets, and you can see that some cases the NMIOU value represent much more accurately the distribution of the results of these models than the CMIOU value, and this indicates the problem of the standard aggregation strategy of the NMIOU. So importance of diverse attacks. So on this image, you can see which attacks perform the best on some scenarios. So basically, as you can see, every attack has a contribution to the whole. So basically, there is no such a subset of the attacks which is dominated every other attacks. Therefore, every attack has contribution to the ensemble. So basically, if you intend to evaluate most accurately the higher amount of the robustness of the models, you have to use every attacks that was provided in this paper. So our conclusion, none of the already published models are robust. So basically, we have to find new strategies for robust semantic segmentation. We provided new attacks, and we show that every attack has a contribution. The already published ones and our new attacks has contribution too. we show that there is a slice bias, so we have to use another aggregation strategy to of the MIU to evaluate the models correctly, and we created the currently most accurate higher bounds of the robustness of the models. And thank you very much for your attention.